A company finds that its marginal revenue from the sale of the x unit of its product is given by r prime of x equals 8x squared minus 7. Assuming that r of 0 equals 0, find the total revenue function r. We're asked to find the revenue function, and we're given marginal revenue. So usually if we have revenue, we want to find marginal, we take the derivative. So given marginal revenue, our revenue function will be equal to the antiderivative of r prime. So 8x squared minus 7 in this case. So r of x is equal to, I'm going to add one of the exponent and divide by my new exponent. So 8x to the third over 3 minus 7x plus c. Okay. This one here is a case of a particular solution. I need to solve for c. But we were given information to solve for c. We know that r of 0 equals 0. That means that r is equal to 0 when x is equal to 0. So I will plug that in here. So I have 8, 0 to the third over 3 plus 7 times 0 plus c. So this means that c is going to be equal to 0. Therefore, my revenue function, r of x, is equal to 8 thirds x to the third minus 7x. A company finds that consumer demand quantity changes with respect to price at a rate given by d prime of p equals negative 3,000 over p squared. Find the demand function if the company knows that 838 units of the product are demanded when the price is $5 per unit. This is very similar to the previous example, except for solving for c is going to require more work. Because we know that our demand is changing with respect to price, so we know that dp is given by this function right here. So if I want to know what the demand function is, I'm going to take the antiderivative. So I've got a negative 3,000 p to the negative 2. Adding 1 to my exponent, I get p to the negative 1 divided by my new exponent plus c. So right now I have d of p is equal to positive 3,000 p to the negative 1 plus c. And like I said, I have to find c. We are told that the company knows that 383 units of the product are demanded when the price is $5 per unit. So that means the demand, x, is going to be 838 when the price, p, is $5. So I'll plug that in down here so I can solve for my c. So the demand, d of p, is going to be 838, and that's equal to 3,000 p to the negative 1, so over p, so over 5 plus c. And now we solve this for c. So I'll get 838 is equal to, this becomes 3,000 over 5, that's 600 plus c, and then I'll subtract 600 from both sides. So c is equal to 238. Therefore, my demand function, my particular solution in this case, d of p, will be equal to, sorry, I'm doing it from right here, 3,000 p to the negative 1, so over p plus 238. A rock's acceleration at time t is given by a of t equals 24t, and its initial velocity is 18. Find the velocity function. Okay, so if we know, like I said, part of this is knowing the relationship. So if you have distance and you take the derivative with respect, this is respect to time, then you're going to get your rate or your velocity. And then if you take the derivative of velocity with respect to time, then you're going to get your acceleration. So to go backwards, you're going to use antiderivatives. So velocity, so v of t, is going to be equal to the antiderivative of my acceleration. So the antiderivative of 24t. So we've got v of t. I add 1 to my exponent, divide by my new exponent plus c. So right now I know that velocity is going to be equal to 12t squared plus some arbitrary constant. And now I've got to figure out what that arbitrary constant is. We are told that the initial velocity is 18. So that means at time 0, so when t is equal to 0, my velocity is equal to 18. So 18 is going to be equal to 12 times 0 squared plus c, so that means c is equal to 18. Now I have my velocity function is 12t squared plus 18. Find the average function value. So we're supposed to find the average function value of the function y equals 6x squared minus 9 over the closed interval -1 to 4. We have to know the formula for this one. So our average function value is going to be 1 over b minus a, and then the definite integral evaluated from a to b of our function f of t dt. Okay. A and b are going to be your endpoints in your closed interval, and then f of t, this is our function. Okay, so my average function value for this example then is going to be 1 over, I have 4 minus a -1, so, and then I'll evaluate from -1 to 4 of my function 6x squared minus 9. So this will give me 1/5, and then when I take the antiderivative, I get 6x to the third over 3 minus 9x. I'm going to simplify that in the next step. And so we have 1/5, 2x cubed minus 9x, and then we still have to evaluate it from -1 to 4. Some students like to distribute the 1/5 first, but you could go ahead, get your function values, and do the 1/5 afterwards. So that's when to set it up. So I'm going to take 1/5, and then I'm going to plug in my 4. So 2 4 to the third minus 9 times 4. I'm going to go ahead and get this number right now. So I get, let's see, here we go. I get 92. 92. And then minus 1/5. Oops, let me do this, minus 1/5. Now I plug in a -1 everywhere. So 2 times the -1 to the third minus 9 to the -1. And this works out to be 1 minus 7. So I got 1/5 times 92 minus 1/5 of 7. So this will give me 85 over 5, which is 17. Okay. So 17 will be my average function value over that closed interval. The life expectancy in years of a certain type of computer chip is a continuous random variable with probability density function given below. Find the probability that a randomly selected chip will last from 2 to 4 years. Okay, so 2 key pieces of information is I'm told that this is the probability density function. That means I can use it to find the probability, for the life expectancy. And then the question is to find the probability that it will last between or from 2 to 4 years. So probability lasts between 2 and 4 years. That's what I need to find. Okay, so we set up a definite integral. I will evaluate it from 2 to 4. And when x is between 2 and 4, I'm using this function. So I got 5x plus 5 to the -2. Right, so really it's a matter of evaluating this definite interval. I am going to use substitution for this one. Let me bring my 5 out front. And then the x plus 5, I'm going to let u equal x plus 5. So this will be u to the -2. And my du is 1 dx. And so I already have got that there as well. So now we have u to the -2 du. I take my antiderivatives, I've got my 5, I add 1 to the exponent, u to the -1 over my new exponent. I'm still going to have to evaluate it. And so now substituting back in again, I got my 5 and my -1 here. So I have a -5 and then my u to the -1. And now I'll evaluate from 2 to 4. Okay, I will plug in my 4. So I have a -5 and then 4 plus 5, that's 9. So over minus, and I plug in my 2, so I have a negative 5 over 2 plus 5, so that's over 7. You can work it out with decimals. You can get a common denominator. If you get a common denominator first, and again end up with 10 over 63. And then converting to a decimal, 0.1587, bunch of stuff. The directions do ask us to round to 3 decimal places, so I will go with 0.159. So that is the probability that our randomly selected chip will last from 2 to 4 years.